Hello everyone, welcome to the class once again. I hope you're all doing good and the best of your health. I hope that you've enjoyed all the lessons in this chapter, Kinetic Theory, and I hope that you have seen every minute details of this chapter. We have discussed about pressure, we discussed about how the pressure is related with the velocity, the root minus square speed of the gas, and with the density of the gas. That is P equals to 1 by 3 rho v square. We discussed about kinetic energy, that it is directly proportional to temperature. We also discussed about different kinds of speed, the most probable speed, the average speed, the root mean square speed in this chapter. Now in today's class, we'll be checking questions on JEE Advanced pattern on the kinetic theory chapter. Now first of all, let me tell you, JEE Advanced can ask question from this chapter. The question will be simple if they ask objective type involved with the concept of kinetic theory. Then the question will be simple. If you have solved many problems in this chapter, you can certainly solve it on the day of your examination. Without taking more time, let me just go ahead with the first question of JEE Advanced Pattern exercise in this chapter, Kinetic Theory. First, two non-reactive monatomic ideal gases have their atomic masses in the ratio 2:3. So atomic masses are given in the ratio 2:3. So if I take two gases A and B, their atomic masses are in the ratio 2:3. So let me say that Ma by Mb is equal to 2 by 3. This is what has been given. We are taking two gases A and B. So for that I have used Ma and Mb, their atomic masses. The ratio of their partial pressures when enclosed in a vessel kept at a constant temperature is 4:3. So pressure of A to pressure of B is 4:3. So let me also write down here pressure of A. Here I am using PA, PB for partial pressure for both A and B. So PA is for partial pressure of A, PB is for partial pressure of B. So PA by PB 4:3, that is what has been provided in the question here. The ratio of the densities, we need to comment on the densities of A and B. So the required thing in this question is you need to evaluate what is the ratio of the densities of A and B. Let's try to find out what will be the ratio. Now you see here the ratio of the density. Before that, just let me write down the ideal gas equation. Ideal gas equation says that PV equals to nRT, we all know that PV equals to nRT, this is the ideal gas equation. Now from this equation, how we can actually reach onto the density of gas? For it, you see pressure into volume will be equal to N. N can we write if the total mass of gas is capital M and its molecular mass is m naught. So can we write N as m upon m naught. M naught is molecular mass, m is total mass. Here I am writing separately. M is mass of gas that has been taken in the container, and m naught is molecular mass that's easily identifiable, molecular mass of gas. From here we all know that density will be what? M upon V. So if I make the subject m upon V, so we will be obtaining m upon V will P into m naught by RT. This is what we are going to obtain. M upon V is the density. Let me write down this as rho, that will be equal to P into m naught by RT. Clear? First thing, I believe that this would be clear to you about the density of the gases, how you can actually reach onto a formula to identify the density. We have to compare the densities of A and B. So let me write here, comparing the densities of A and B, we can write rho A by rho B is equal to PA MA upon RT and PA MB upon RT. And since temperature is constant in both and same in both, so because they are kept in the same container, so temperature will be same. PA MB upon RT. Done, done. Now very simple to identify that rho A by rho B, that is their density, are in this ratio as this equation identifies. Pressure of A upon pressure of B, that is what I have written, pressure of A upon pressure of B, that is given as 4/3. and Ma upon Mb will be 2 upon 3. So 4 upon 3 multiplied with 2 upon 3, 4 into 8, 8 upon 9. Done. So that means the density is in the ratio 8:9. Rho A by rho B. Clearly, from this equation we can reach on to this conclusion that density will be in the ratio of 8:9. Let's check with the given option. A 1:4, no. B 1:2, no. C 6:9, no. It's D 8:9. So if you know the equation, if you can actually relate the equation, if you can actually change the form of the equation of ideal gas equation, you can actually reach to the answer very easily. This question was asked in previous advanced examination in just a few years ago, so you should know that such question can be put up in your advanced examination. If you can proceed in this way, if you have practiced question, it will not be difficult for you to answer question from this chapter. Let's go to the next question. A mixture of 2 moles of helium gas. 2 moles of helium gas, atomic mass 4 atomic mass unit, and 1 mole of argon gas, atomic mass 40 AMU, is kept at 300 Kelvin. In a container, the ratio of the RMS speed, V RMS of helium upon V RMS of argon, is. We need to compare the RMS speed. Now, first of all, you all must be remembering the formula for the root mean square is related as under root 3 RT by molecular mass. So if I have to compare velocity of RMS of helium upon velocity of RMS upon argon, so we will be using RMS for helium upon RMS speed of argon. This will be equal to under root, since this is in the denominator, temperature is remaining the same for both. You see here, a mixture of 2 moles of helium gas, atomic mass this much, and 1 mole of argon gas is kept at 300 Kelvin in a container. So temperature is same, that will be cancelled out. So here we will be having mass of helium, molecular mass of helium upon molecular mass of, wait a minute, this should be, argon should be in the numerator because argon should be the numerator because I am not in the denominator here, so it will come in the numerator. So molecular mass of argon upon molecular mass of helium. Under root molecular mass of argon, that is given as 40. You see atomic mass 40 atomic mass unit. So place here 40 divided by molecular mass of helium. If you see here, helium molecular mass is given as 4 atomic mass unit. Substitute its value as 4. Clearly you will be obtaining this as under root 10. Under root 10 is nearly equal to 3.6. 3.16. Let's check with the given option. 0.32, no, this is not the answer. 0.45, no. 2.24, no, and 3.16, yes. Under root 10, 3.16. So write this. In this way we can obtain. This question was asked in a previous year examination. So I believe that you'd be having the idea what questions can be raised in this chapter. Next question, question number 3. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. 2 moles of oxygen and 4 moles of argon at temperature T, neglecting all vibrational modes. The total internal energy of the system is A4 RT, B15 RT, C9 RT, D11 RT. Now, I have told you about the internal energy, how it is related to degree of freedom. The internal energy is related with degree of freedom as provided here. Internal energy U is equal to N F by 2 RT. This is how it is related. N is the number of moles, F is the degree of freedom, divided by 2 R into T. This is how internal energy is related with the temperature and the degree of freedom and the number of moles. Gas mixture consists of 2 moles of oxygen and 4 moles of argon. So 2 gases are there. So internal energy of oxygen plus internal energy of argon. Oxygen is diatomic. For diatomic, degree of freedom is 5. So for oxygen, degree of freedom will be equal to 5 since it's a diatomic. For argon, the degree of freedom will be equal to 3 since it is monatomic. So, reason it's diatomic and here it's monatomic. Substitute all the values for N, F. Now, here you see U will be equal to N of oxygen into F by 2 RT plus N of argon F by 2, F of, let me write here oxygen as O2 and F for argon as FAR divided by 2 RT. Now, let us put up the values for the number of moles. Gas will consist of 2 moles of oxygen and 4 moles of argon. 2 moles of oxygen, 2 into 5 by 2 RT plus 4 into 3 by 2 RT. Clearly, it is 5 RT and he will be getting 6 RT. So, 5 RT plus 6 RT, 11 RT. 11 RT is the total internal energy of this combined system of two gases, oxygen and argon. So, let us check the option number A 4 RT no, B 15 RT no, C 9 RT no and D 11 RT yes. We reached on to this 11 RT. So, if you know how to actually what formula is used for internal energy of a gas, you can clearly answer this. Hope that it won't be a problem for you all in remembering all these basic simple formulae for all such concepts. Fourth, two identical containers A and B with frictionless piston contain the same ideal gas at the same temperature. Two containers you see here with frictionless piston contain same ideal gas. So, same gas, it means molecular mass will be same temperature is same, and so it will be isothermal process will be taking place and the same volume V. Volume is also same. The mass of gas in A is Ma and that in B is Mb. If mass is different, volume is same, temperature is same, pressure will be actually different for both the gases. The gas in each cylinder is now allowed to expand isothermally. Isothermally, temperature remaining constant to the same final volume 2V. The change in the pressure in A and B are found to be delta P and 1.5 delta P respectively. Then A 4 Ma equals to 9 MB, B 2 Ma equals to 3 MB, C 3 Ma equals to 2 MB and D 9 Ma equals to 4 MB. So, we have to compare the mass of gas in A and mass of gas in B. So, if we take two containers as I show you here, container A and B, they are identical, same volume. With a piston, they are also having a piston. So, let me just show you the piston part also. Now, this will be okay. Now, see here, initial volume is V and temperature is same. So, temperature T is same for both the gases. This is gas A and B container that I have marked, they have same gas. So, let us say molecular mass we are taking as m naught in both the containers, molecular mass is m naught, and let me, since gas is same, I will just quickly show you the gases. The mass of gases A and B are different. So, let us say mass is Ma here and Mb is here, that is what has been given. Let us see the question once again. Two identical containers A and B with frictionless piston contain the same ideal gas at the same temperature and the same volume V. The mass of gas in A is Ma and that in B is Mb. The gas in each cylinder is now allowed to expand isothermally to the same volume 2V. Now, let us say initial volume is V. Initial volume is V, let us say this. Now, we all know that isothermal conditions, so initial pressure into volume will be equal to final pressure into volume. This is what we can actually comment for each of the gas. Now, you see, try to understand, we have to relate the mass of gas. We all know that pressure into volume is equal to nRT, first thing. N can be written as mass of gas divided by the molecular mass, RT. This will be pressure into volume, we can write in this way. Now you see here, if I talk about pressure situation, initial pressure will be what? If from this equation, if I talk about initial pressure PV equals to nRT, from this equation, initial pressure P1 will be equal to nRT by V. Clear? N will be same in both the cases. Now change in pressure, now final pressure if I talk about P2, final pressure, that will be equal to nRT by 2V. Temperature is remaining same, number of moles will remain same. Now there is a change in pressure, you see a change in pressure, if you see it's delta P for A and 1.5 delta P for B. If I talk about change in pressure, let me write down here, since it expands, temperature remains same, pressure is going to decrease. So I am using final change in pressure will be equal to minus delta P as per given, because it will be finally it will be reduced. So this will come out to be minus delta P will be equal to, let me write down here, minus delta P will be equal to P2 minus P1. So nRT by V, nRT by V 1 by 2 minus 1, you will be obtaining this P2 minus P1. This applies for A, this applies for A. Similarly for B, now you see for B initial pressure will be still number of moles divided by, and this is number of moles for A, let me keep here separately, number of moles of A RT, and here P1 will be number of moles of B RT by V, and P2 will be number of moles of B RT by 2V. So similarly again change in pressure P2 minus P1 is equal to minus 1.5 delta P, because final pressure will be reduced. It's given 1.5 delta P, it will be reduced, so I am using minus sign. Okay, what I do not need this part, let me rub this part, I hope that you would have taken down. Now P2 minus P1 equals to minus 1.5 delta P, and if we use that minus 1.5 delta P is equal to P2 minus P1, so NBRT by V, NBRT by V 1 by 2 minus 1, we can use this. Next thing what we need to find, we need to find out how MA and MB are related. So if we divide this equation number 2, let us say this is equation number 2 and this is equation number 1 we have arrived at. So what I am going to do, I am going to divide equation number 2 divide by 1, will be having 1.5 is equal to NB by NA. This is what we can comment on number of moles in B divided by number of moles in A. So number of moles in B will be what? MB divided by molecular mass, that is M naught. This is MA divided by molecular mass M naught. So 1.5 is what? It can be, we can write that as 3 by 2. Here we get 3 MA is equal to 2 MB. This is what we are getting, 3 MA equals to 2 MB. Let's check 3 MA equals to 2 MB. Clearly option number A 4 MB 9 MB, no, 3 MA equals to 2 MB, so this will not be satisfying. This 2 MA equals to 3 MB, no, 3 MA equals to 2 MB. This is what we are attaining, this is what we are reaching. 9 MB equals to 4 MB, no. So I hope that you have got how to solve this. Very simple question, all we need is the usage of ideal gas equation and how we can actually convert the number of moles in terms of the mass of gas provided and the molecular mass. This question was also asked in the previous year examination. Hope that you have understood what questions are being raised in your JEE exam. So if you have practiced, it's not a tough examination. If you have practiced enough, if you have solved different kinds of questions, you would get an idea what kind of questions do examiner actually is trying to seek from you all. Next question, fifth. The average translational energy and the RMS speed of molecule in a sample of oxygen gas at 300 Kelvin are 6.21 into 10 to the minus 21 joule and 484 meter per second. Respectively, the corresponding values at 600 Kelvin are nearly for the energy and for the root mean square speed. Now I'll be doing very quickly this. Kinetic energy is proportional to temperature. Let me tell you, it is exactly proportional to temperature, and Vrms under root 3 RT by m, so it will be proportional to under root of temperature. So if I write final kinetic energy divided by initial kinetic energy, we can write this as equal to final temperature divided by initial temperature. So final kinetic energy will turn out to be final temperature divided by initial temperature into kinetic energy initial. Final temperature is what, 600, initial temperature is 300, that is what has been given. So 600 by 300 multiply with kinetic energy, that is 6.21 into 10 to the power minus 21 joule. This is what that has been given. Clearly you can see this, just twice of the initial kinetic energy will be the answer. It will be 12.42. The final kinetic energy will turn out to be 12.42 into 10 to the power minus 21 joules. This is what you will be obtaining for the value of final value of kinetic energy. Just have a quick look on the given answer. See, 12.42 10 to the power minus 21 joules, so this can be answer. 8.78 10 to the power minus 21 joule, no. 6.21 10 to the power minus 21 joule, no. And D also can be answer. So two options will be eliminated. Just we need to check the root mean square speed. Now I also told you about how root mean square speed is related with temperature. So we can say that V2 by V1 will be equal to under root of, or let me use TF and TI. F and I will be using final RMS speed upon initial RMS speed is equal to under root of final temperature divided by initial temperature. So final temperature is what? 600 divided by 300, you are going to get under root 2. So this implies that the final RMS speed is equal to root 2 times of initial RMS speed. I have used RMS, let me just write this as VF is equal to root 2 times of VI. Multiply this with initial RMS speed, that is given as 484. 484, if you are going to use it here, so just a minute, it's 484 meter per second, that is what has been given. Root 2, that is 1.414. So this will be nearly, if you just try to do it, it will be getting around 684 meter per second. That is what you can check the calculation, or you see the options. If you check, it will, here it is given just twice of nearly 484, so this won't be the answer. This cannot be an answer. The only option left will be this. This is the most probable option. Although you may not get exactly 684 meter per second, but this is the more appropriate answer. So you have to check the option number D. You have to cancel option number A. I hope that you have obtained the result for this question. Only thing you should know the relation between temperature and kinetic energy and temperature and root mean square speed. So you will be getting the required result for this. Okay, I believe that you have understood this question number 5. It was good and it has been asked in the previous examination. Let's go to question number 6. If 1 mole of a monatomic gas gamma equals to 5 by 3 is mixed with 1 mole of a diatomic gas gamma equals to 7 by 5, that is the adiabatic constant for both the gas has been provided. The value of gamma for the mixture is, so we need to find out what is the value of gamma for the mixture. Now we all know that the gamma is what? It's the ratio of Cp by Cv. This is the gamma. Now let me tell you how you can identify the Cv for a mixture. We all know that Cv is equal to N1 C1 plus N2 C2 divided by N1 plus N2. This is the formula to find out the Cv for a mixture. Next thing you see, N is the number of moles, C is the molar specific heat at constant volume. Here you see monatomic gas. What is the value of the specific heat capacity at constant volume for a monatomic gas? That is actually equal to 3 by 2 R. So let me go ahead and let me put here this as equal to N1, that is 1 3 by 2 R plus N2, that is again equal to 1 5 by 2 R. This is what you have to place divided by 1 plus 1, that is 2. So this will get you 3 by 2 R plus 5 by 2 R, that will be 8 by 2 R. So you will get 4 R by 2, that will be equal to 2 R. This is the value of CV for a mixture that has been provided. Now you see here we need to find out the gamma, that means we also need CP. CP is equal to CV plus R. CP is equal to CV plus R, that is equal to 2R plus R is equal to 3R. Now gamma, as I told you, it is Cp by Cv, that is 3R by 2R. Clearly 3 by 2 you are going to get, or 1.5, that will be the value of gamma. 1.5, let me just clearly check it. 1.4 no, 1.50 is the right answer, 1.53 no, and 3.07 no. So 1.50 is the right answer for this question. Hope you have understood how to find out the gamma for a mixture. Next question of the class, question number 7. Now this is more than one option correct. So we need to be cautious enough to choose which all of the options are best suited for the answer. Let V bar, that is V average we are talking about, V RMS and V probable, respectively denote the mean speed, root mean square speed, and most probable speed. That is generally the symbol for all these three kind of speeds of the molecules in an ideal monatomic gas at absolute temperature T. So monatomic gas, temperature T is provided, the mass of a molecule is m, then A, no molecule can have a speed greater than root 2 V RMS, B, no molecule can have a speed less than Vp by root 2, C, this is a relation between Vp is less and V bar is more, and then V RMS is the highest. The average kinetic energy of a molecule is 3 by 4 mVp whole square. Let's go ahead, let's try to find out how we can actually evaluate this. Now first of all, let me talk about option number A. No molecule can have a speed greater than root 2 VRMS. See, a molecule in a gaseous container can have any speed. We never commented that this is the maximum speed, this is the minimum speed. They can have any speed. So we cannot say that no molecule can have a speed greater than root 2 VRMS. No, you cannot make a comment on this. A option will be incorrect. B, no molecule can have a speed less than Vp by root 2. Again, we cannot comment on the minimum speed of the gas, so it can be even less than this also. So this is also incorrect. Now there's a relation between VRMS, V bar and Vp. So first of all, let me give you the formula for VRMS. Under root 3 RT by M. Now V bar, that is equal to 8 by pi RT by M. 8 by pi RT by M. This is nearly equal to 8 by pi. If you do, it will be nearly equal to 2.5 RT by M. Let me mark down, this is nearly equal to 2.5 RT by M. Next, if I talk about most probable speed, this will be equal to under root 2 RT by M. So we are getting this. We are getting VRMS is the highest, then V bar, then Vp is the lowest. So most probable speed is the lowest, as you can see. So the relation will be Vp and here V bar and then VRMS. So this is a relation between all the three speeds that I have given you. So clearly this is the speed. For the third one, how to actually check the average kinetic energy of a molecule is. Now average kinetic energy of a molecule in terms of RMS speed, average kinetic energy, that is half m V RMS whole square. It's given in terms of V most probable speed, Vp. So we know that Vp is equal to what? Vp is equal to under root 2 RT by M, and VRMS is equal to under root 3 RT by M. If I divide VRMS by Vp, if I divide this, we will be obtaining VRMS y Vp is equal to under root 3 by 2. This is what you are going to get, under root 3 by 2. So VRMS will be equal to under root 3 by 2 Vp. Therefore, V RMS is equal to under root 3 by 2 Vp, that is what you are going to get. Under root 3 by 2 Vp, that is the formula for V RMS. Next you see, if I replace this V RMS here in the kinetic energy formula, let me rub this. If we replace this, we will be getting kinetic energy is equal to half m V RMS whole square, that is 3 by 2 Vp whole square. We can write in this way. This will turn out to be 3 by 4 m Vp whole square. So in terms of most probable speed also, we denoted the value of kinetic energy of each of the molecules. So average kinetic energy of if molecule is 3 by 4 mVp whole square. This also correct response. C and D are the right response for this. So let me show you that C and D are the correct answer for this question. Good question has been put up in previous year examination. I hope that you have understood how to solve such kind of questions. Question number 8. From the given following statement concerning ideal gas at any given temperature T, select the correct one. A, the coefficient of volume expansion at constant pressure is same for all ideal gases. We need to comment on this. B, the average translation kinetic energy per molecule of oxygen gas is 3 kT, K being Boltzmann constant. C, the mean free path of molecule increases with decrease in pressure. D, in a gaseous mixture, the average translational kinetic energy of the molecule of each component is different. Now, see here, let me talk about first the coefficient of volume expansion at constant pressure is same for all ideal gases. Constant pressure, we all know that PV equals to RT. This is what we can comment. We need to talk about at constant pressure how the volume expansion is related. Pressure is constant. If I take differential, I can write P delta V equals to R delta T. So if I write number of moles also, NR also, then also it will not make any change. I am taking differential. So delta V by delta T, this is the coefficient of expansion at constant pressure. Pressure is not changing. This will be NR by P. Pressure constant, this N is constant, R is constant. This term delta V by delta T, this is the coefficient of volume expansion. You can see here the coefficient of volume expansion. You can take that. This is the coefficient of volume expansion, delta V by delta T. So clearly that is constant. So now you see the coefficient of volume expansion at constant pressure is same for all ideal gases. So if pressure is same, N is the number of moles you can actually keep same. So R is same. Yes, that is the correct statement. So option number A clearly suffice. B, the average translational kinetic energy per molecule of oxygen gas is 3 kT per molecule of oxygen gas. The average kinetic energy in terms of temperature is given as 3 by 2 Boltzmann constant into T. This is what we have derived. For one molecule is 3 by 2 kT. It's not 3 kT. So B is incorrect. C, the mean free path of a molecule increases with decreasing pressure. Due to decrease in pressure, what will happen? The molecules will have more space to move more randomly. That means it's going to have more space, it will move more randomly. So mean free path is going to increase. If you increase the pressure, the molecule will have less path to move. So mean free path will decrease. Here the mean free path increases on decreasing the pressure. Mean free path of molecule increases. Yes, it increases on decreasing the pressure. So C is the right answer. D, in a gaseous mixture, the average translational kinetic energy of the molecule of each component is different. D, in gaseous mixture, the average translational kinetic energy of the molecule of each component is different. This statement try to understand. If you take a gaseous mixture, if I divide into various components 1, 2, 3, 4, 5, 6, 7, 8, let there be different components that I have divided it. Now try to understand mixture, you have taken the average translational kinetic energy of molecule of each component is different. Since the average translational kinetic energy depends directly on temperature and the Boltzmann constant, that is what it remains constant. So it will be same, it won't be different, it's a mixture, it's kept in the same container, temperature will be same. So they will be having the same kinetic energy, not different. No, incorrect. Correct option will be A and C for this question. So I am putting here A and C, you need to mark for this question, not choose B and D for this one. Hope that you can identify all the things we have learned in the class and how you can that relate to the questions that has been put up in your examination. Let's go to next question, question number 9. Integer type, that means you will be having one integer as the answer. 1 mole of a monatomic ideal gas is mixed with 1 mole of diatomic ideal gas. The molar specific heat of the mixture at constant volume is XR. Molar specific heat is given, the value of X is. Again, this kind of question we already discussed, and you can see that same question can be repeated in your JEE advanced examination. 1 mole of monatomic ideal gas is mixed with 1 mole of diatomic ideal gas. CV we need to talk about. I'm just repeating this thing we have already done, and same question can come in your JEE advanced examination in repetitive fashion. What one thing we can learn from here? In your JEE examination, the pattern may change, but the thing they are seeking from you will remain the same sometimes. So if you have practiced previous year problem, that will be of great help to you all in solving the question on the day of your examination. N1C1 is a monatomic gas, 1 3/2R plus 1 5/2R divided by 1 plus 1. So again you will be getting 4R/2 2R. Clearly it's given that CV is equal to X into R. Comparing this, we get X is equal to 2. This is what we obtain, X equal to 2. So the integer that you have to circle on the OMR sheet, that will be 2. 2 will be the answer for this. Hope that you have obtained how to solve such kind of question. Question number 10, statement, and it's an assessment written type question, and which option to choose, A, B, C, D? Let me just clarify this. Option number A, you need to choose if both 1 and 2 are correct and 1 is the correct explanation for the the second statement is correct explanation for the first statement. B, you have to choose if both are true but the second statement is not the correct explanation. C, you have to choose if one is true, second statement is false. D, you have to choose if one is false and the second statement is true. I hope that you can already identify what I have said, how you can actually make out from A, B, C, D which option you will be choosing after reading these statements. The total translational kinetic energy of all the molecules of given mass of an ideal gas is 1.5 times the product of its pressure and volume. Let's be very quick to check it. The total translational kinetic energy, we all know that kinetic energy is given as 3/2 RT, and that will be equal to 3/2 RT can be written as pressure into volume. So you can write 3/2 PV, so that is equal to 1.5 PV. So as statement number 1, this total translation kinetic energy of all the molecules of a given mass of an ideal gas is 1.5 times the product of its pressure and volume. This statement is true. Statement is true. 2, let us check it is true or false and whether it's a correct explanation for statement number 1. The molecules of a gas collide with each other and the velocities of the molecules change due to the collision. In any gaseous system, the molecules randomly collide with each other and they even collide with the walls of the container in which it is kept. And during this collision, they impart momentum to the neighboring molecules and to the walls of the container. When they collide, their velocities do change. Yes, that's true. So their velocities of the molecules change due to the collision. Yes, this is the correct statement. But try to understand, this is not the reason for the energy. It will be dependent on pressure and volume. And here this will not be, this is not the explanation for statement number 1. This is true, but not an explanation. Let me write down, this is true, but not an explanation for 1. So what we can make out, this is not an explanation for 1. So A you have to choose when both are true and second statement is the correct explanation. So A you will not choose. B, if one is true, second is true and this is not the explanation. So you have to choose option number B for this question. So let me write, you have to circle option number B. This is the option you need to choose for this question. Hope that you have got all the questions we have discussed in this session. Hope that you enjoyed this session. Hope you have learned what kind of questions can be put up in your JEE advanced examination based upon this chapter. This chapter has simple formula, speed, energy, pressure, all the simple relations. Hope you can actually remember all the formula. Do memorize all this formula. pressure equals to 1 by 3 rho v square, Vrms, how it is related with temperature, how energy is related with temperature. So I hope that after building up all this concept, this will be of great help to you all. I'll meet you all in the next session. Till the time, thank you everyone and wishing you all the very best.